here we go. So we're going to talk a little bit more about how we solve for these equations, okay? And what's the really important thing to know, okay? So I think you guys are okay on the concepts. It's usually the math that's throwing you off. And I think the math is throwing you off because a lot of you are not taking the time to write out the variables like I do. Okay, I'm gonna be honest with you. I've probably been solving these equations longer than you've been alive, and I'm not exaggerating. Okay, so I'm pretty good at. I could really actually probably solve them without writing them down, but I'm writing them down because that's what you should be doing. Okay, so let's first start with impulse. Okay, and then I'll go back and help everyone with momentum if they have issues. Leo, can you see okay? Yeah, I can. Okay. All right. So the first thing I want to do is talk about these two equations over here. Yes? Somebody say something? Okay.
I'm sorry, my mic turned off.
Okay. All right. So the first thing I want to talk about is these two equations right here. All right. So remember, you guys just have, you don't have to write down everything, but this is just on paper, okay? And I'll tell you what, when I finish this, I'll put it in your notebook, okay? All right, so the first thing I want to do is explain to you that these two equations are the same equation, okay? They are the same equation. What does I stand for? I stands for impulse, okay? So I stands for impulse, and the formula for impulse is F times T, okay? Because that is the same thing. I is equal to F times T, F times T. That's why this and this are really the same thing, okay? That's the first part, okay? Then it says I is equal to this triangle is called a delta, okay? All it means is that something changed, okay? It just means that it changed. So for instance, I could say a delta in terms of the temperature, okay? There was a delta in temperature today. Well, yeah, it was cold this morning and then it warmed up, okay? So that's all that means. Now, what did P stand for? Anybody remember what P stood for?
Momentum. Oh, shoot, sorry.
Momentum.
Yes, momentum, exactly, okay? P stands for momentum, okay? So when I'm looking at this P, okay, here's P for momentum, all right? P is momentum, and momentum is mass times volume, okay? That's what momentum is. That's how we calculate it, mass times volume, okay? Well, instead of just saying P, if I say delta P, that means something about the momentum changed, okay? Well, it can only be the mass or the velocity. Based off this equation, what do you think changed? Based off of this equation, what changed? What is this? What is listed twice, but there's two different numbers for it? The V, okay? There's an initial velocity and a final velocity. So this is just the same thing, all right, as me saying VF minus VI, okay? It's the same thing, all right? So that's why this delta P is the same thing. That's why this delta P is the same thing as this MVFI, okay?
Miss Peyton, I'll be right back.
Okay. I cannot stress to you guys enough how important it is to know your symbols and your units. If nothing else, half of the battle is knowing your units, okay? I don't care if you see this huge number. Let's say you see 25,000, okay? As long as you see, for example, kg behind it, automatically you should be thinking that this is a what? A mass, okay? You don't have to know how to necessarily solve anything, but at least I know where to put it because it should go wherever there is an M in the equation, okay? It doesn't matter what number I write, as long as you see kg, you should know it's a mass, okay? You have to know your units, okay? I'm gonna make you go.
When looking for the mass.
Anytime you see kg, there's gonna be a number in front of it.
V, right?
I'm sorry?
It's P over V, right?
Kg.
Oh.
Anytime you see kg, it is a mass, okay?
Yeah.
I want you to know your units, if nothing else, because that's half of the work when it comes to solving this. Some of you guys are trusting your calculators, and I don't know if you know this, but chances are whatever you put in your calculator, it's gonna give you a number. It doesn't mean it's right, okay? It will always give you a number unless you use like double operations or something, okay? So kg is always mass. What about ms? Good. Carla, what about ms? What is that describing? You there, Carla?
Final and initial velocity. No, wait. I forgot it. Yeah, final and initial velocity.
Very nice. Anytime it's some type of velocity. It doesn't matter if I have a 10 here, a 3,000, a 22 million, as long as you see ms, you should know you're filling in for a velocity, okay? We have to know our units, all right? So make sure you know your units, okay? All right, so I put all of these equations here, okay? Just to show you that at the end of the day, all of these equations, all of these equations, all are the same thing, including these, okay? It's all the same thing. It's just a matter of, maybe I said I, or maybe I said ft. Maybe I said P, or maybe I said M times VF minus VI, but they're all the same, okay? So if you know your units, you can work it out, okay? So let's practice that, okay? Let's practice our units, okay? All right, I'm gonna give you a problem, okay? And we're gonna see, can we solve it? So let's do this, we'll do an easy one first. All right, when you see a problem, this is what I would suggest you do. And I know it's hard because you guys are online, but you can still write down, for example, if I didn't have paper, I would go look at this and I would say, well, here's a 46 NS, 46 NS. I'm going to use that somewhere. And here is an 0.8 S. Right, Leo? Yes. Okay. So, Leo, let me ask you this. Wait, I'm not asking. Now, I want to make a good point, and I'm not putting him on the spot. But as soon as I got ready to ask Leo a question, guess what he did? Picked up his calculator. We haven't even talked about what this stuff is yet. Do not pick up your calculator yet. First, let's figure out what it is. Second, let's figure out the equation. Then you can pick up your calculator, okay? Get out of that bad habit. Now, Leo, 0.8 seconds. The number is irrelevant right now. But the fact that this ends in seconds tells me what?
It's time.
Very nice. Leo said this must be time. I'm going to label this with a T because it has to be time, okay? Antoine, this says 46 NS, okay? Maybe we don't know the unit for that yet, but if you read this sentence, can you guess what the 46 NS is?
Force.
Don't follow the masses. If you read this sentence, can you tell me what you think 46 NS is? Can you see it? You think it's force? Does it say force? Does it say force?
No, it says like hit.
A racket hits a tennis ball with an impulse of 46 NS. Anybody want to guess? What do you guys want to guess? You sure?
Yeah.
All right, Garrett, what do you want to guess?
46 impulse.
All right, how'd you know it was impulse, Garrett?
Because one of the impulses
Impulse.
Oh, what just happened? It says impulse, right? It says impulse. So I'm gonna assume this is impulse. Don't listen to everybody, okay? All right, this is impulse. What's the letter for impulse? Not a hard one. I, very nice, Esther, thank you.
Wow.
All right,
Wow.
here's I, here's T. All right, Antoine, your chance to redeem yourself. Put that up, okay? What are we looking for? What do they ask us to solve for?
You're looking for it.
Is that what it says? You tell me.
Well, oh.
Are you sure?
Yeah.
All right, so Antoine says they are asking us to solve for force though. He said, what is the force? Fantastic. Now I know I need some formula that has an I, an F, and a T. Looking here, do you guys see any formulas that have an I, an F, and a T? Looking there, not at me. Anaya says she does. Pamela, do you see a formula that has an I, an F, and a T? You can just tell me yes or no. Oh. She's in the restroom. Okay. All right. Anaya says yes. Anaya, can you tell me what the formula says? FT. Yep, we just need I, T, and F. Do you guys see anything that has just I, T, and F? I'll take anybody.
I equals FT.
All right, Anaya says I equals FT. I do see that. All right, I equals FT. It's right here. All right, so now that we know this formula, Leo, should we plug in the numbers or pick up our calculator? What do you think? This is a trick question, by the way.
Calculator?
Trick question, Leo. No, we need to plug in our numbers first. All right. I, do we have a number for I, Leo? Yes or no?
Number for I,
Did we find I in this and does it have a number?
no.
No? You don't see I written anywhere with a number under it?
Oh, yeah, 46.
Okay, great. So we're going to plug in 46. All right. 46. So we got that written in. Anybody see a number for F? I don't see a number for F either. I'll leave it as F. All right. So F, this is F times T since they're next to each other. Do we have, Esther, can you tell me if we have a number for T? Silence. Eric, can you tell me if we have a number for T? Natalie, can you tell me if we have a number for T? Oh my goodness.
Yes,
Thank you.
0.8.
Thank you, Natalie. All right, 0.8. Now, here's the, and I know I'm going slow on this first one, but I want you guys to understand the importance of this, okay? So now we have these numbers, okay? Guess what? I can put 46 and 0.8 in the calculator any kind of way, add, subtract, multiply, divide, and it's going to give me a number. So you need to know how to solve for F, okay? We need F to be by itself, okay? So for us to get F by itself, some of us are really good at this, okay? Some of us not so much. If I move the 46 to the other side, there's nothing left on the left side. That's not going to give me anything. It's going to be F times 0.8 divided by 46. I can't put F in the calculator, okay? We need F to be by itself. So because F is being multiplied by 0.8, Leo, what's the opposite of multiplying?
Dividing.
Dividing, okay? I'm going to divide, I want F by itself, so I'm going to divide this by the 0.8, okay? 0.8 divided by 0.8 looks like a 1, so it cancels out. If I do it to one side, I have to do it to the other side, okay? 46 divided by 0.8, so that leaves F on this side by itself. F is equal to 46 divided by 0.8. Somebody tell me what the answer is.
7.5.
Naya says 57.5. I need a unit. Joelle, can you tell me the unit for this? We're looking at force. The unit for force never changes.
kilograms, my MS. I forgot what's the M for.
57.5 N.
But
For
yeah,
force,
momentum. Yeah,
wait,
the
wait, wait.
kilograms, meters per second.
Okay, so, but you said momentum, right? I thought we were solving for F.
Yeah, I mean they're both the same, no?
57.
Whoa, no. Force is totally different from momentum. Here's momentum over here.
N.
We're solving for F. And then what'd you say? I think that was Esther.
57.5 N.
N. This is why it's so important for us to know our units, guys, okay? If I had given you some answer choices and I had given you this, you should have scratched it out because we're not solving for momentum, we're solving for force, okay? All right, questions on this one? I would strongly suggest you guys are writing this down
Oh,
because
okay. Also,
when you write them down, well, no, too late, I'm gonna erase this now. Listen, guys, you do not remember things as much if you are just listening or if you think you just, I don't know, take a picture, whatever. You need to write this stuff down. You literally have a muscle memory between what you wrote down and your brain. Have you not ever taken a test and been like, okay, I remember highlighting this, right? But you're not gonna be like, I remember what it was on that screenshot. You're just not, okay? All right, any questions before I erase this?
should I copy it?
You should have been writing it when I was writing it,
Oh,
but I'll put it up later. All right, here we go.
okay.
Next question. All right, I'm gonna do one of these. Let's do this one. All right, same thing, okay? We're gonna go through and label things. So you can either write all your variables out or whatever. All right, so here we go. Wayne hits a stationary 0.12 kilogram hockey puck with a force that lasts for 0.01 seconds and makes the puck shoot across the ice with a speed of 20 meters per second, scoring a goal for the team. With what force did Wayne hit the puck? All right. We can start anywhere, but let me start with this. Let me see. Let's see. Ladarian, are you there?
Miss Peyton,
Yes.
the way that I solved mine was like I just put it instead of doing the I then triangle or whatever that is. I put this time and then I equaled it to what the
Did you solve it? You mean for this one or for the other one?
for this one I solved it differently, but I still got the same answer.
For this,
I
we
got it
haven't
correct.
solved this one yet.
No, I'm saying like I got for the impulse one I got everything correct, but I was like I did it differently than do you
Okay,
think?
shoot me a picture so I can see how you did it, okay?
Okay,
All right.
I'll take a picture.
All right, so here's what I want to ask first. Eric, are you there?
Yeah, I'm here.
Okay, I just have a quick question for you.
Yeah.
Can you tell us, when you read this, can you tell us what we are looking for? Everyone should be able to see what we're looking for.
Force, because it asked what force did Wayne hit the puck.
Thank you very much. All right, so Eric says we're looking for force. All right. Garrett, what's the letter for force? Not the unit, but the letter that represents force, like in an equation. Not the unit, but just like force is. So one of these letters over here. What do you think force is?
P.
V?
P.
P? You sure?
Oh.
I'll give you a hint. It should be pretty obvious. Yes, it is the F. All right. So we're looking for force. That's what we're looking for. All All right, looking for force. So if you're writing notes right now, you could write F is equal to question mark. If you're writing notes right now, you can write F is equal to question mark because that's what we're looking for. All right. Now, Pamela, are you there? Sarah, are you there?
Yeah.
Okay, Sarah, when you read this, can you tell me anything you think we're going to use? Like, I'm just going to underline it. Like, can you tell me something you think is important that we're going to use in our equation later?
Time, right?
Okay, do you see time somewhere? Can you tell me where you see it or what it says?
Isn't it 0.01?
Very nice. So Sarah says 0.01 is the time, and she's correct because time always ends in seconds. All right? Somebody give me something else that we're going to use at some point.
Mass.
Okay, mass. Very nice. All right, so Natalie said mass. Natalie, which one do you know where the mass is?
0.12.
0.12, she said, is mass. That's because mass always ends in kg, always. So right now, if we were writing stuff on, if you're writing notes and you want to write stuff on the side, you can say M is equal to 0.12. And we also found that T was equal to 0.01. All right. Still got something else. What else we got? Very nice. Anaya
Velocity.
said, very nice. Natalie and Anaya said they see a velocity. What do you see? 20 meters per second. Very nice. All right. Is that everything? That's the velocity. Is that everything?
Yeah.
Yeah? Okay. So we got a velocity. Do you have an equation that has just F, M, T, and V? Just has those four. Do you have an equation that has just those four? Or do you see something close to that?
That one?
Which one?
The one highlighted in green?
This one?
Yeah.
Very nice. Leo says, this one looks pretty close. What's different though?
There's two V's.
There's two V's. So maybe we're missing a V. So look at the problem. See if you see another V possibly, or some word that could be maybe mean that we have another V. Stationary. Thank you, Kevin. So Kevin says this word stationary. Okay, that means something is not moving. If something is not moving, how fast is it going? Anybody? Yes, 0 meters per second. So now we just need to figure out which V is I and which one is F. Which one do we think is the initial velocity, where it started? Very nice. Anaya says this one, because it started as not moving and then he hit it. So this must be VF. All right, so now let's go fix this. This is now VF and VI is equal to 0. All right, so now that we got that, we can go write that equation that Leo was talking about, okay? All right, so I'm gonna write the equation and then I'm just gonna plug in the stuff, okay? So we got FT is equal to MVF minus VI. All right, and I'm gonna plug in stuff. Leo, did we have a number for F?
No.
Nope, didn't have a number for F. Naya, did we have a number for T?
Yes.
Yep, 0.01. So I'm gonna write it in first, then we can go back and use our calculator because we got it set up, okay? All right, equal to something times something minus something. All right, M. Natalie, did we have a number for M?
Yes.
Yes, we did. 0.12. And then you guys told me that VF was 20, and then VI was 0. All right, now we got everything plugged in. Now we're almost to the point where we can use the calculator, okay? We actually are at the point.
Is that x times?
Yeah,
X
it's
times
time.
0.1?
Yes, times. Okay, F times 0.01. All right. Who remembers PEMDAS? Please excuse my dear Aunt Sally. What order of operation do we have to do first? Parentheses, 20 minus 0. I can do that in my head, thank goodness. 20 minus 0 is still 20. And now I get to multiply that by the 0.12. All right. Still haven't done anything with this stuff on this side. I know this is low, guys, but if I slide my screen, it's gonna go away. All right, I don't got my calculator, so you guys need to tell me first, what is 0.12 times 20? 2.4 now it says. So I'm gonna go to the side over here so I can have more room, guys. So F times, wait, what did you say it was?
Oh, I said it was 2.4.
Now I said over here, that was 2.4. We still have this 0.01. Now remember, we want F by itself. So we have to do the opposite operation, okay? If you get this far, it's fantastic. But it doesn't even matter if you put in your calculator wrong, okay? We need F to stay on that side by itself. So we're not gonna move the 2.4, we're gonna move the 0.01, okay? So I'm gonna divide this side by 0.01 so that the F stays on the side by itself. And I'm also gonna divide this side by 0.01. And Anaya, because she's my favorite calculator over here, is gonna tell me my answer. Joelle, I'm about to come back to you in just a second.
240.
240, all right. Anaya said the number she got was 240. Joelle, you there? Joelle. Now he's missing. All right. Carla, are you there?
Yes.
Okay, Carla. We just solved for force. I need a letter to go back here. A unit. What do you think? What's force?
N.
In, very nice. Good job. All right. Questions on this one,
No, I'm trying to understand it.
okay? Okay, so here's what I want you
Why
to
did
do.
you highlight stationary?
Because stationary means not moving, and that's the speed that we needed. So that was 0 meters per second.
What's a puck?
Puck is,
Oh, that little disc that they.
mhm. All right, anybody have questions on this one? Okay, I want you to take, we probably will just play Among Us on Tuesday. That'll be a good refresher because we got a long weekend and we're probably gonna forget a lot of stuff. So here's what I want you to do. I will slowly work through another problem, okay? I'm not gonna talk about it, I'm just gonna work, but I'm gonna work very slowly. So you can watch me if you want. If you feel much, much better about this, okay? I want you working on the momentum practice and the impulse closer. Please be writing on paper before you just pick up your calculator so you can get it right, okay?
I already did the momentum.
If you did not get a good grade on it, I would like for you to do it again. That's everyone, okay? If you got a good grade on it, fantastic, that's awesome, okay? But I'm just asking if you don't get a good grade, do it again, okay? All right, any questions before I stop the recording?
Is there an impulse practice?
Yes, there is.
Okay.
Okay, I'm gonna stop the recording.